In this problem, we want to answer the question, how many 10-bit bit strings have exactly 4 ones? Remember, a bit string is a string of zeros and ones. Each of the positions contains a bit, which is either a 0 or a 1. So let me write out some of, let me write out some 10-bit bit strings with 4 ones in them. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 positions. 10 positions. And they have exactly 4 ones. Okay, so you just choose where you have 10 positions, you choose 4 of them to be ones. All right, here's one of them. Here's one 10-bit bit string with 4 ones. Right, if those are the places where you choose the ones, then the zeros are determined, right? Because if those are where your 4 ones go, then your zeros have to go there. Okay, what about another one? Let's do 1, 1, 1, 1. Then 0, 0, 0, 0, 0, 0. There's another 10-bit bit string that has exactly 4 ones. Oops. Let's make another one. Okay, let's see. How about 1, 1, 1, 1? That determines where all the zeros go. Here's yet another 10-bit bit string with exactly 4 ones. Okay, so how many of these are there, right? We've just written out 3 of them. Well, how many of them are there total? How many total? And this is where n choose r comes in. Let's think about how you would say this. Think about how you would say 10 choose 4. You would say 10 choose 4. We call it 10 choose 4 for a reason. And here's an example why. You have 10 positions, choose 4 of them to be ones. Right? So there's 10 choose, so the answer to this problem is 10 choose 4. You have 10 positions, choose 4 of them to be ones. And the way you can think of this with sets now, because remember 10 choose 4 is the number of 4-element subsets of a set with 10 elements. So the way you can connect this to that idea is, say this is position 1, position 2, position 3, position 4, position 5, position 6, position 7, position 8, position 9, and position 10. Right, so the set, the 10-element subset that we're going to choose from is exactly the set P1, P2, P3, all the way up to P10. So our 10-element subset that we're counting the number of 4-element subsets, right? And so a 4-element subset of this, right, would be, let's see, P1, P4, P8, and let's do P10. So this 4-element subset of the set P1 to P10 that has 10 elements, this corresponds to this bit string. 1 there, a 1 there, a 1 there, and a 1 there. So 10 choose 4, right? So we have 10 choose 4 is the number of different ways that you can choose 4 of these positions to be ones. All right, so the answer is 10 choose 4. You could literally put that for the answer. I'd be perfectly fine with that. 10 choose 4. There's your answer. 10 choose 4. If you want to use the formula to figure out exactly what number 10 choose 4 is, you can figure out that number and put it in there. You'll get the answer right as well. So to me, 10 choose 4 is the same as whatever that number is. If you do the actual math and get the number, that's fine too. Right, so you could do this computation, 10 factorial, 4 factorial, 10 minus 4 factorial, and get whatever 10 choose 4, whatever number that is. But to me, that if you get this number and you put that number in there, that's correct. Or if you just write 10 choose 4, that's correct as well. Either way is just as good. Okay, now from a previous example, see, now that I have you here, I want to point something out. We have a perfect position. We're in a perfect position to have this pointed out. 10 choose 4 is the same as 10 choose 10 minus 4. Okay, 10 minus 4, as you know, is 6. So I proved it with 5 choose 2 and 5 choose 3, but the proof can be extended to all of these. There's a mapping between 4-element subsets and 6-element subsets of a set with 10 elements. But what does that mean? So 10 choose 6 is the number of 6-element subsets of a set with 10 elements. All right, so what does 10 choose 6 count? 10 choose 6, that counts where you put the zeros. Right? If there's 4 ones, then there's got to be 6 zeros. And so the number of different ways that you can, the number of different positions, the number of different ways that you can choose 6 of these 10 positions to be zeros is the same as the number of different ways that you can choose 4 of these positions to be ones. Right? And that's exactly what this says right here. The number of different ways that you can choose 4 positions to be ones is the same as the number of different ways that you can choose 6 positions to be zeros.